Hi, this video is an introduction to proofs for just regular people who get nauseous just even thinking about it. First, I want to talk about the parts of a two-column proof. There's other types of proofs, but this is the one most people are familiar with and most teachers give for homework assignments. Two columns mean, there's obviously a column here and a column here, and then there's multiple rows depending on how long the proof is. Well, at the top of each column, or we call that the header, there's always two words. And the first word on the left side is statement. And the word on the right side is going to be reason. And you're going to list a bunch of statements and reasons. Okay? Then the other parts are all your statements and all your reasons, of course, right? When there's also the instructions to the proof, or being asked for the proof. So normally when you're asked for proof, you'd get something like this: given, and then you'd get a list of things that you're told. And it could be a picture, and it could be in writing. So I'm just going to say blah, blah, blah. We'll just say given blah, blah, blah. All right? And then you're told to prove something. Okay? It'll say given blah, 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 comma, prove, and then that can be anything. It could be two triangles are congruent. It could be just anything. So I'm just going to say X, Y, Z. That's what you have to prove, is this sentence or statement. So the thing you have to prove, the kind of cool thing about that is that you always know whatever this is going to be your very last statement. It's always going to go right down here. Okay, so you actually can kind of complete part of your proof by just putting it down there. You may not know the reason for it yet, but you can at least put this down here. So I could just put a little row right there. Also, all of your givens, all of these things, if there's, here in this case, let's say there's 3 of them. Sometimes there's 1 thing, sometimes there's 2, 3, 4, there could be 6 things. They all go at the very top under the very first statement. Just easy, you just list them. You could either list them each individual one in a separate row, or you could list them all together. Whatever you prefer. There's no right or wrong. I could just put 2 and then put another one. The reason for all of these is the word given. So it's kind of like if you were given a gift. It's a present to you. It's the first part of your proof, and you can think of it as a gift. Now, you can repeat this word given by just drawing a little arrow, or some people like to do the double apostrophes. You can do that too. You can do something like this for each line. Okay. All the stuff in the middle, it could be one more line. It could be 14 more lines. It could be a bunch of lines. But all that stuff is stuff you add. Okay, because you think of it. All those statements. And for every line, you need to have a reason. Okay. One reason for each statement. And you could repeat a reason like we did here with given, and then just draw arrows. But you need to identify the reason for each statement, and you have to understand that the reason that you give goes with the statement right to the left of it. They're like a dog and its tail. They're attached. So if these two in the same row go together, this reason I would put here on the right would explain how I got that statement on the left from above, because you're just going down from the information above, adding on to it. So let's try one, or try a couple actually. But I'm going to show you how to do this using something you are already comfortable with. If you're in geometry, you've already had algebra, and you've had equations. Only you've never had to do a proof with equations. So let's just take a typical algebra equation, something like this. Just say 50. Okay. You would normally, some people would actually write down each operation they're going to do as a separate line, and then bring all the information down. So I would take away 3 from both sides. Remember, whatever you do to the left, you have to do to the right. So I'd bring that down, and then I'd get 2x equals 12. I might show that I'm dividing by 2 here, and then I would have x equals 6, okay? But another person might take the same equation and just do this. Start with 2x plus 3 equals 15, and they would just go right to 2x equals, 15. Okay, 2x equals 12. And then on the very next line, they write x equals 6. When you get to higher level algebra, usually the second year algebra that you take after geometry, you do it this way. You don't show all of these steps here. Where you're at, you don't show the actual part where you're actually adding, subtracting, multiplying, or dividing each side. You just go from one line to the other, just doing one thing. That's what I'm going to want you to do today, is just go from one line to the next, just performing one operation on both sides. Now, the fact that you can perform all 4 operations, add, subtract, multiply, and divide, on both sides of an equation and have it still remain equal, those are all called properties of equality. Okay? So properties of equality. And there's 4 of them, and they are addition, because when you add both sides, that's addition, of course. When you do subtraction, that'd be the subtraction property of equality. So you just say addition property of equality, subtraction property of equality. Obviously, we've got multiplication property of equality. I left out the, there we go. Property of equality, and last, of course, division. All right. Well, I've got them all spelled out for you on the next page. And we're going to try a couple proofs, kind of using this, but you've never had to explain your reason for each line, so we're going to try this on a couple. Okay. And by the way, all these reasons, there's 4 main kinds of reasons. Well, we'll just list them. We've got theorems, and you can usually find theorems in the back of your book in the appendix. They show up in each chapter. We've got postulates, also known as axioms, and those usually come right at the beginning of the book. We've got definitions. You could say, definition of congruent, or definition of an angle, or something like that. Theorems, postulates, definitions, and then also properties. And the ones that we're doing right now are properties. And you can use all of those as your reasons. I listed the 4 properties of equality right here: addition, subtraction, multiplication, division. We also talked about given on the previous page. That's the reason that you use for all the stuff they just give to you. Now I want to talk about a couple more, especially for algebra, although you can use these in a geometric proof. Simplification. The difference between simplification and all of these properties of equality is that when you simplify, you don't actually change the amount or the value of the sides of the equation. You're not adding, subtracting, multiplying, or dividing. You're doing things like combining like terms. Or you could be rearranging the equation, but you're not changing the value of it. Okay? So that's one reason that I want to add on. And then the distributed property. And you should be familiar with that. You use that when you see parentheses like this. And you take the factor on the outside and you multiply all the factors inside the parentheses by that factor. So 2 times 2a would become 4a, and then 2 times 3 would become 6. Okay? So we're going to use these 2 in addition to the word given, in addition to all these properties of equality. I do allow plenty of abbreviating in my class. And in fact, all this property of equality, I just tell my kids to do POE is fine with me. Now, if it was like a state test or something, I would write it out. But let's try one. So we're going to do, this is our request. Given 3x minus 9 equals 12, we're supposed to prove this. So I'm going to go ahead and just make a big T-chart. That's my table. And over here I'm going to write the header statement on the left side, and I ran out of room there, and then reason over here on the right. Now, as I said, all I got to do for the first one is just list your given. Well, this is my given right here. I've only got one. 3x minus 9 equals 12. And so my reason is given. Yay, got a present. Okay. I also know my very last statement is going to be x equals 7, because that's my goal, is to get down to here. Okay, so you can list it down there. It sort of helps you know where you're going. Since we've all done a lot of algebra, we'll just um, work through it. The first thing that we would do here is add 9 to both sides. So I would write 3x equals 2 plus 9. Oh, I wrote that down wrong. It's supposed to be 12. That's what I've been bugging you this whole time, right? 12. Okay, so if I add 9 to 12, I get 21. All right, 21. All right, now, so from this line to this line, I added, okay? So the reason over here explains how I got this line right here. And what I did was I added. So it's the addition. I'm just going to put addition, add, and then a period, POE, because I'm abbreviating. That stands for addition, property of equality, from above. Okay, I'm going to draw another line. Oh, I actually can go from this all the way down to x equals 7, simplify by dividing. Because I'm going to divide both sides by 3, and I would get x equals 7. So we would just call that the division property of equality, or POE. And we're done. Now I tell my kids, if you have a bunch of leftover white space here, it's not a problem. Just, you can, if it really bugs you, you could erase this down here and bring it up, or just draw a little line like that. I just hate to leave it all blank, because I think someone could fill it in with something else. I don't know. Who would do that to you? Okay, let's take this one. This is our given, 3. Oh, wait, I got to write my headers first. Let me start this. 3 times 4x minus 1 equals 9. Okay, let me write statement and reason at the top. Never want to forget that. Alrighty. The reason for the very first one, of course, is given, because it was given to me. Alright. I do know that my very last statement is going to be x equals 1. You can go ahead and write it right down here. I don't know the reason yet. So looking at this, the very first thing I would do is the distributive property. Now, some other people might do it differently. They might divide both sides by 3. I'm going to go ahead and use the distributive property just to show it. So 3 times 4x is 12x. And then 3 times this minus 1 is minus 3. If I don't need to change the 9, because all I did was distribute it over here on the left-hand side. Okay, so that's just a distributive. And I'll put a little period there. Distributive property. Okay, now I would go ahead and add 3 to both sides, and I would get 12x equals 12. Okay, adding 3 is going to make this negative 3 go away, or the minus 3 go away, and adding 3 is going to make your 9 turn into a 12. Okay, to go from this line to this line, I added 3, so it would be the addition, and abbreviated POE. All right, now to go from here to the next line, well, look, that's easy. We just divide both sides by 12. That's going to be called the division. That's my dishwasher, by the way, in case you're wondering. All right, so far so good. I'm about to show some more. If you'd like to try it, what I recommend you do is that go ahead and pause the video as soon as you see those, and then just scroll it ahead when you're done, to see if it looks like your answer. So do your own on paper. I'm going to go ahead and just kind of without talking, I'm going to walk through these, and you can follow along or do it to yourself. Take away 4 from both sides, and we're going to have negative 5. Taking away 4 from both sides is subtraction. And here I would multiply both sides by 5. So I would get x equals 25. Now that was what I was going for right up here. So I'm done, but I still need to explain how I went from this line to this bottom line, and I multiplied both sides by 5. So multiplication property of equality. Out there. That's it. I don't really need this extra little tail there. Okay, let's do another one. Over here, I'm going to draw columns and rows. Statement. Always, always, always. Reason is always on the right. I'm going to just write down the given right here. And that is my given. Okay. On the very next line, in this case, this is something we haven't done yet, I would combine my like terms. And combining like terms is simplifying. So my negative 2x and my positive 6x will become 4x. I'm going to call that simplify. Okay, and then on this, I would take away 1 from both sides. So that's subtraction. Alrighty. And last, I would divide both sides by 4 and get x equals 2. And that's division, POE. So once you start to get a feel for doing proofs, for something you're comfortable with, which is algebra, doing it for geometry, just knowing really looking at the back of your book, being familiar with your typical reasons, and just understand the basic format of a proof. If you did like this video, please leave a comment below or like it, and I would appreciate that. Thank you.